there is no reason of course why you have to condition only on y, you can equally well condition on x. So likewise we will have, we also have what, f of x y given x. This argument I am going to deliberate, right, you can put any symbol there, it does not have to be x or y, it can be anything, could be r, z, w, whatever, but the value of x that you have, you put here. The subscript says that it is a new PDF obtained by conditioning x equal to something, again the same notation given. So you have two vertical lines here, a vertical line here and a vertical line here. This is what you need to know. So what is this? So so I have written this. So likewise, if I want to put x here, I just have to, the numerator note will be the same, in the sense we will have the same form. Numerator always uses no matter whether you condition on y or conditioning on x, this numerator is just the joint PDF evaluated properly. Of course you will put x naught comma y if you are going to use y out here instead of y comma x. So that is why I am putting y, the conditioning I am indicating with a y naught or whatever. If I remove this, if I call this y equal to y, then it becomes even more confusing, right. You do not know what is this, right? These two numerators will look identical, but it is better to indicate the conditioning value with the subscript, just so that you know that this is a right, it's a constant, you are not going to change. Once you freeze this, that is your observation, you are not going to change it. Whereas the argument of the function can be anything. And again there is a new omega y, sorry, new omega x in this case, omega y in this case. This is all important, right? You cannot, I cannot underestimate the importance of finding that new range condition based on the conditioning that we did. So as I wrote here at the bottom before I erase, once again I repeat, these have to be found first, not, it is better to know what you are looking for and then go look for it, rather than blindly apply formulas and then try to figure out where the formula is valid. So let us go and apply all this to our one example with darts, the so called darts joint PDF, right, where fxy xy was given to be some 1 by pi r squared for xy inside the circle of radius r, centered at the origin, right. We do not have to so of course we have to draw it x y. So now we know that omega x and omega y are both the set minus r to r, does, I can close or open, does not make much of a difference anyway. So we just write it like that. So I can pick any, for conditioning I can pick any value in this set. That means that the x coordinate or y coordinate took that value, that is all, right. So the dart landed somewhere there, its x coordinate was whatever, what can I say about the distribution of the y coordinate, that is what we are trying to find. So let us say we do this. If I draw a vertical line, it means obviously we are doing this, we are conditioning on x. If I draw a horizontal line, it means we are conditioning on y. So let us say we are conditioning on x. So let this be the conditioning event, right, x equal to x naught. So what is the new omega y now? Clearly it is not the same old as the old one. If you say that the dart landed with the x coordinate equal to x naught, that means that your y can only vary like this, which is the new omega y. Since this is my notation or my terminology, I am putting it within quotes. So this is going to be what? This is going to be the range r squared minus x naught squared minus root of this to, or I can write it as a closed interval, but you can whatever put a comma here, might to plus, no this is, so this to that basically. Okay. Now once you've written that, then it's all we have to do is plug it in. So what is the f of y given x given y given x naught is basically f of what, x y x naught comma y divided by f x of x naught. Now I need the results from the, earlier this week. When did we derive this? We derived it on Monday. So why don't you do it and tell me what does this come out to be? Why should I do all the work on the board? Do it and tell me, and I will write the result after you tell me so that it's there on the on the tape. But till then, I'm going to pause. The numerator we already wrote is 1 by, what is the denominator? The nice thing about the numerator is that we assume it does not change with x or y. It may be a bad model, but it is a simplest model. Somebody asked me, how good is it? It is probably not very good at all, because you have to make R very large to assume that all the darts will only fall inside that circle and never outside. And then once you make that assumption, it is very highly questionable that the joint PDF is going to be constant throughout that circle. But it is not worth our time here to break our head on what is a better model, because we are not throwing darts at boards anyhow, right. So we are going to stick with the simplest case, right. So 1 by pi r square is a numerator. What is the denominator? Wait, 2 by, there is a pi also somewhere, no? 2 by pi r squared remains, and then root of x r squared minus x naught squared. This was done in a previous class, which I hope that even people viewing this on tape later on will rewind and get it out, right. So, but anyhow, so what happens here? All of these things will cancel, and what do you get? 1 by for y in this. Actually, I need not have put a y here. I can erase this and just say, since I put a y here, so that thing can be cut and pasted right there. So you can see how the parameterization by x naught comes. This is a uniform PDF, by the way, right. It's not it doesn't vary with y, but it varies with x naught. How does x naught change matters? It changes the height of the PDF. So you get actually degenerate PDF for x naught equal to r. It turns out that if you say that x naught is going to be exactly equal to r, that means y also has to be r. In this particular case, observing x naught equal to r removes the uncertainty altogether. Y can only take the value 0. But that does not matter. I mean, those things are sort of subsumed by this expression. So the fact that for some values of x naught this may degenerate is not such a, it's after all those are all 0 probability events, so we do not care too much about right, about the extreme cases. So do you see the parameterization? Is it clear? X naught occurs here also. The extent x naught controls typically the extent of the PDF, the new PDF, and it also controls the height. And this is one of the simplest examples. If you take more complicated examples, as we will do in the homework, you will get more complicated dependence on x naught. This is once again clear to everybody. Okay. And it turns out because of the extreme symmetry in this particular situation, you can easily reverse the roles of x and y, you will get something extremely, you will get something very similar. What about the important case of x and y being independent random variables? What happens then? Start from there. Actually, maybe I should have kept that heading, but anyway. So, for independent xy, observing makes no change at all. That should be obvious, right? So, for all y equal to y naught, f of x given y, you can just write it like this is fx, and f of for all x equal to x naught, I am not even going to write the rest of it, f of y given x will be fy. And there is no question of any new omega x and new omega y, it will be all the same old whatever you started with. New omega x in this case, right? Just put omega x here. What you started with? What else can we do with these conditional PDFs? It turns out, as we said some time back, they are very useful in defining conditional expectations, but that is jumping the gun at this point. What we can do is evaluate probabilities based on, in this case for example, if you say x equal to x naught, what is the probability that y is between this and this? You can get that by integrating this. So, the universe is now collapsed to just x equal to x naught. So, you can find probabilities of various events as given x equal to x naught. I mean, in this case, since you only have two variables y and x, typically that you look at intervals of y. So, that you can straight away do given this conditional PDF.